All right, everybody, I got to go because I've been struggling to get started on this because there's so much to teach you and it's hard to do it in 5 minutes, but I hope I'm ready. What does it mean to solve a polynomial equation? Well, you might have something like this in life: x cubed plus 2x plus 2x squared minus 9x equals 18. So that would be a polynomial. Here we have a polynomial, and here it's an equation. Now, I want you to know the best way to solve this is to subtract 18 from both sides and then find the zeros. So when we solve a polynomial equation, we will get solutions, but they may also refer to those as zeros or even as roots, okay? All right. Okay, so let's say we have an equation, x cubed plus 2x minus 9 minus 18 equals 0, and we want to solve it. Well, there are going to be up to 3 roots. Remember, a root is just a solution. And so we are going to look at this power, the highest power. Sorry, this should be a 2x squared, and this should be a 9x. We're going to look at the highest power to predict the most amount of roots we can have. Okay? Now, if there is one real root, one real solution to this, then there will be 2 imaginary roots. The imaginary roots you're going to find always come in pairs. So there has to be an even amount of imaginary roots. And what I want to do here is throw this into my graphing calculator, which I already have. So let's look at this. I'm going to not graph that one. Okay, so here I'm only graphing this one because it's the only one who's equal sign. Let's take a look at that. So as we often get here, our curve crosses the axis here, here, and here. So that means we have 3 real solutions to this. It looks like the solutions are at -3, -2, and +3. Well, let's take a look at our table and see if we're right on that. -3 gives us 0, -2 gives us 0, and I'm sure that +3 will also give us 0, okay? So we have 3 real roots for this solution. And if they wanted us to list out the solutions, we would say x equals -3, -2, and 2. Those are all real numbers, okay? Now, what if we wanted to find the solutions to x cubed plus 512? Gosh dang it. Equals 0. Well, let's take a look at the graph again. Okay, so now what I'm going to do is I'm going to highlight this equal sign, and I'm going to unhighlight that equal sign. And now let's graph the other one. Now see how this graph is all jacked up. So what happens when that, I'm going to go to zoom, and I'm going to go to zoom 0. And that kind of fits it to our screen for us. Remember, this is 512 right here. But most importantly, I want you to see that there's only one real root for this. Okay? And notice, if I go to my table, the answer is at -8. So then what happened to our other 2 answers? What are the other 2 answers? Well, to do this, it's going to get pretty complicated. Today, you're going to learn how to factor. The only cubic thing we can factor is the sum and the difference of cubes. So you probably don't know this, but this is actually x cubed plus 8 cubed. Okay, so here's this is the only cubic we can factor other than ones that are just a constant times a quadratic. But how do you factor this? You remember same, opposite, positive. So if you have this, we can rewrite that as x plus 8. This is your same, times, well, we got to have an x squared so we get back to an x cubed, minus, this is your opposite, and here we have 8x. Is that right? And then positive, always a positive here. And there you'll have 64. And if you were to multiply these together and do all of your distributed and then combine like terms, you would end up back to this, x cubed plus 8. Okay, so now let's take a look. That makes sense. Look, we had x equals negative 8. Well, that comes from this one. So then what does this give us? Well, that one must have imaginary solutions. So if we set this thing equal to 0, x minus 8 positive 64, put it in our John Rick, and indeed, you get x equals 4 plus 4i radical 3 and 4 minus 4i radical 3. And these are your three solutions. Okay, you have one real solution and two imaginary solutions. Remember, if you graphed a parabola and it looked like this, there were solutions, but they were imaginary. So that's essentially what's going on here. One of your solutions is real, the other one is imaginary. But now, real quick, if you had x cubed minus 512 equals 0, how would you do that one? Well, the same thing, same, opposite, positive. So you do x minus 8. Keep in mind, this is x cubed minus 8 cubed. So you do x minus 8 times x squared plus 8x plus 64. Okay, so again, same here, opposite there, positive there. So then you would set this equal to 0 to find the imaginary solutions. I don't have time to do that in my 5-minute video, so you're going to have to come and talk to me about this if you're a little bit confused. Okay, so the only other time we could factor a cubic is if you have something like this, x cubed plus 10x squared plus 24x equals 0. Well, let's start by just graphing it. Okay, so here I've got it in my graphing calculator. Let's graph it. Now, I don't like the way that looks, so let's go back to Zoom 6. So I can see this. This one has 3 real solutions. It looks like the solutions are at 0, -4, and -6. So yeah, x equals, we just did this, -6, -4, or 0. Well, you could have factored this one because look, there's a common factor. You could say x times 24. Oh my gosh. Excuse me. X times x squared plus 10x plus 24. Okay, I factored out an x. Now, that's like x minus 0 if you want to think about it like that. This thing is factorable, and you won't be shocked to find that if you factor that thing, you get x plus 6 times x plus 4. So what are the solutions there? X equals 0, -6, or -4. So those are the kind of the ones that you can factor. factor out an x, and then you can put that in your quad 4 program, or just factor it by hand. So that's about as much as I can teach you in 5 minutes. I know this isn't enough. It's probably about time for you guys to start asking me for some clarification. I'll keep doing my best.